Hello everyone, I just want to document and I guess make my first major and in-depth tutorial, help guide, whatever, on how to make a basic speaker enclosure. I have had some stupidly oversized speakers in my room for a while. I had ceiling mounts put in place for them. I wanted to make some much smaller, lighter, mid-range speakers and just use a separate subwoofer. And I want to make those soon. I'm gonna, I guess, go through the process of showing what I'm using, how I'm designing it, and how I make it, and how I test it. So starting off with what I have, I'm using these speakers. I've got a few of them hanging around. The Fountek FW168s. They're a pretty good speaker from what I can see. I find it interesting that it says it's an aluminium cone, but it feels like plastic to me. But I'll trust the description for now. I'm not endorsing Parts Express. This is just where I got it from. And they are handy for having all the parameters you need. I'll show you that in a second. So the most important thing about this speaker, it's a relatively flat response. This blue graph here, I think, is just your phase. Oh no, sorry, that's your resistance. This is your response, your frequency level at your output frequency. So it's relatively flat. It starts to get pretty wonky at, where is this? So around 4,000 kilohertz, sorry. But a lot of people suggest cutting it off at around 2,000 hertz or 2 kilohertz, which is quite in line with the tweeters or high range speakers that I want to use, which have a good cutoff at around 2 kilohertz as well. Then it starts to drop off there, so I'll use both of these speakers at a 2 kilohertz crossover. And if you don't know what a crossover is, it's it can either be software or hardware, just where the frequency response, or where this speaker will stop producing at that frequency range, and where this one will start kicking in, pretty much. So I'm using pretty old software actually, just to guess or to verify the enclosure, since here it suggests, here we go, where is it? It suggests an optimal enclosure volume. I just want to go with sealed because it's nice and small, and I have no reason for a loud volume which a vented enclosure will give me. I prefer the higher response rate of the sealed enclosure. So this suggests, no, that's in cubic foot, but it's around 5 litres. And so I just entered in all these values when making my driver range here, because it doesn't have it built into the database, which I can't be bothered updating anyway. And that's just a bunch of these values. I entered them in there, then did a rough box design. It gives me a square design by default, but I need a much bigger front area, which is A and B, because I need to mount more than just the mid-range speaker. I also need to mount a high range one here. So that just gives me a depth of 10 centimeters or 100 millimeters pretty much, and yeah, almost 5 liters. This doesn't know the volume that because I haven't included the other speaker in this, so I might just give this a slightly larger. Oops. Yeah. Lock this in at 5.2, I guess. That's going to crash on me. Anyway, so we're going to have a 1.4 or maybe 102 millimeters, sorry, for my depth, and this will remain the same. As you can see, 100 hertz is roughly where this starts dipping, so that's where hopefully I can use the bass response. I don't have to cut it off, it can just produce whatever it wants, as long as it doesn't create distortion or anything. If it does, I'll have to either use software to limit that or whatever my amplifier can provide. Let's not worry about that so much. So I've got my values that I'm going to use to design my box. So I'll go over to the design program. So this is Fusion 360. It's quite simple, easy to use. I guess I would recommend it if you want something to start 3D design in. And it has I can do not only the computer aided design, I can do the computer aided machining all in one with this software, which I actually want to do because I will cut it out on a CNC machine. But you don't need to do that. A lot of this is a simple box. You could do it, cut it out on a table saw and cut out the hole with a router and a router jig. So I shall make a start. So what I'm not going to do a full tutorial on how to use this software, but I'll try my best. So we're in design mode at the moment, and this interface has changed since I last used it, so I apologise if I'm a bit slow and trying to figure stuff out. So I want to start off with a sketch. I'm going to start off with the x-axis. I'm just going to start off with the internal dimensions. So we had 181 millimeters and 310 millimeters. I'm going to select this outside by double clicking and press O. That gives me offset. I'm going to use 16 millimeter MDF to make this enclosure. So a nice sturdy box. So I've just entered 16 in here, and I'm going to just use the line tool to fill in these lines. Now so what I'm going to do is make enclosure where, so this will be a panel and these two will be their own panel. You could cut it like that. I think it's called a miter cut or whatever, 45-degree cut, but I find it just easier to do it at right angles. I'm gonna paint it all or put a veneer on the outside so it's not going to be seen. And I do sort of like the look of this when you have sort of like a slight offset, but I don't think I'll bother with that for now. I'll do a traditional full box design because I have some veneer hanging around and I need to use it. Alright, so we've got our one plane done here. So I'm just gonna extrude this by, let me put this into perspective so you can see what's going on. So it worked out at 102 millimeters. 110. I know I said 102 before, but I was thinking in centimeters. I don't want 2 extra millimeters, I want roughly 2 extra centimeters, but I'll just stick with 110. Such a small amount's not going to make much of a difference. The sketch disappears when you first do that, so I'm going to re-show it. Select these two, extrude it again. Now that's going to by default join these together. I don't want that. I just want a completely new body. I'm going to hide the bodies and select this. So now I want it to be -16. So I want the rear panel. Once again, select new body. Hide all this again. And show it again. Now I want +16. I want a new body. And I want it to start from here. So now we have, and I'll hide this sketch because I no longer need it. So we now have a box with an internal volume of roughly 5 litres and the external 16mm box thickness. So you see now what I mean by this is its own separate panel that slots in. Oops. So now we need to get our measurements. So I've selected this front. I press C for circle. So we're gonna, before I make this circle actually, let me grab, so we're on the Fountek 168. So the cutout diameter they suggest. Mounting information, baffle cutout diameter. That many inches. I'm hoping this will convert that. Just one thing to note, if you select a point and then move out from there, it'll try to line it up with it. It's awesome, it does select. So move that in by 5mm. So we're probably going to want to rear mount this speaker. So what I'm going to do is make another, the overall outer diameter, which was 7.01 inches, just so I know where to move these things. And that's good enough almost. There we go, 9mm. So that's going to be the outer rim of the basket of the speaker. So I'm just going to, oops, sorry, I haven't been showing you that, have I? There we go. My apologies. I'll just delete that. So starting again, so I'm making a secondary ring here, which was 7.01 inches. There we go. Or not. Why was that playing up? There we go. So notice how now that I've drawn it, I can see, and I hid the front panel just so I can see the inner border of where this stuff is going to go. So the basket, or the whatever, the speaker maximum outer diameter has to not clip with these walls. So I've got a decent gap here. And I can like move it around. Before it was here, so there's a cutout there, which I didn't want, so I've just moved it in here. Now the next step is to focus on the tweeter. So So cutout diameter of that many inches. And the overall outer diameter that we saw before was 4.33 inches. Oops, 4.33 inches. There we go. Yep, and there's the tweeter. I think I'm going to make that front mounted. I'm going to have a little cutout groove for it. That means the distance between here and here and here and here should be roughly the same. So if I grab my inspection tool and just do that, so 26 and 26, it's good enough. So now what I'm going to do is a cut extrusion. So I just need to show my front panel again. And I'll show you this in perspective again. Let's just deal with just the panel. So I'm going to cut to the back of this panel. So this is going to fit our speakers, except for this needs a inner cutout, a channel, which is, if we go to this, we need a bit more information. So the depth of this is 4 millimeters of this baffle plate here. So we want negative 4 millimeters. Yeah, that should be pretty flush. So I'm going to hide that now. So we now have all the, like, this is a real basic box. Let me see how long this video is going for. 17, almost 18 minutes. I'll cut this short. Then the back is going to use some sort of clip mount. What I want to do for starters is have the crossover external. So I'm just going to have 2 sets of pole terminals and not have any circuitry inside. So I will click on here, and this speaker is going to be mounted sideways like this. So I probably, and ceiling mounted, so my cables, probably want to have them come in from the top. And the pole diameter is, well, I think 8 millimeters. I'm just going to set the distance between all these properly. So sketch dimension between these. I want good 30 millimeters between them. Nice definition, I guess, for 5 millimeters. Now, once again, remember that this is inside, this is a front panel that has more room to spare than the inside offers. So I'll just move that over. Actually, I'll do this properly. Set the different distance between these to be 25. Actually, no. Let's go with the same 45. And 45. Gives us plenty of room in here to add our cables and stuff. Now the diameter of these circles, I can change them later. I'm not quite 100% sure of the pole diameter. So once again I'm cutting all the way through to the back of this panel. So that's where our pole terminals are going to be. Maybe I will center that. So I'm just going to edit this sketch again. How to do this? So it's just going to follow one of these. Ooh. Yep, 75 millimeters. See, it just automatically moves the holes. So later on I can just bump up the size of those holes in the sketch and get that all nice. So that is pretty much our basic model. I'm going to do a few other processes which don't need to do on the CNC machine. That'll be like chamfering this front baffle plate and chamfering this. But what I can do is just chamfer it here. So maybe 10 millimeters. Another thing to keep in mind is screws are going to come through here. So you don't want to thin this too much. Might make that 8 millimeter. And I'll select these outer edges. I might chamfer these edges as well, just to see how it looks. So another chamfer. I'll copy that 8 millimeters. So I'm not liking the look of that too much. So I will where's the selection? Damn it. Actually, I'll make this chamfer bigger as well. That's going to be, that's 15. I'll try 13. Yeah, it looks pretty good. Something I didn't note, the distance between these and these is now different because I have different size chamfers. If I choose an 8 again, it becomes the same. I choose 12. So now what I'm going to have to do is relocate this. So if we open this sketch, note it rolls back in history. All this stuff has disappeared, which is obnoxious, but that's just how this program works. I think 3 millimeters will do it. hide that sketch again. And that looks good, but for the sake of knowing for certain, so that's 17. And that's 15. So it looks good, but it's a few millimeters out. So I'll edit this again. I'll just put in 1 millimeter. So that's looking pretty good. Alright, I guess that's enough for now, and I'll end this here before it reaches half an hour. And I'll continue on next time, and it gives me time to think about what to do next. Goodbye.